Please, it's important to note that when you are doing a double integral, supposing you have something like x plus y, okay, let's say xy, like we did before, and then you have x taking values, whatever it may be, 1 to 4, for instance, y taking values from 0 to, say, let's say 2, okay, 1, let's take it from 1 to 2. Now, I'm not concerned about substituting the range. You can do that on your own. But when you are integrating with respect to y, you are xy with respect to y, then it means that x is a constant. So you do something like this, integral x equal to 1. So whatever you are going to do to a constant x, you do that too. So you could bring x out if you like and integrate over y. You have y dx. So y will be 1, take value from 1 to 2. Now, you could do this if you want, or you could just leave x where it is, but treat it as a constant, which means you don't do anything to it. So you're only integrating y. So what happens, or what will happen is that you are not going to have x equals to 1. So this will be here, and then you come here, and then by integrating this, you are now going to have y raised to the power of 2 over 2. So over the limit 2, like that, and then you have the x. Now, that's what your x still will be here. So that's what you are going to have. And then you go on and then say, okay, integral x equal to 1, 4. Then you put this one. You can bring your 2 out. So you have x divided by 2. Now the value for y square. So we are dealing with y square now. Y square can take 2 as a value. If it takes 2, don't forget the 2 here, half here, I've brought it out. So if it takes 2 square, and then you can have it take a value of 1, and then you square that 1, and so you have the x here, and then it will now become, okay, integral of x over 2. This time around, when you do this math, 2 square minus 1 square, that should give you 4 minus 1, and that should be 3. So you're going to have 3x dx. All right, that's settled. X will be taking values from 1 to 4. Now by integrating again, you are now going to have 3 over 2 x squared over 2. So from the limit from 1 to 4 is now going to be equal to 3 over 2. All right, so the 2 here will multiply the 2 down here. It becomes 3 over 4. And then you have x squared. That will be 4 squared minus 1 square. And that will become 3 over 4. 16 minus 1, and that should give us something like 3, okay, 3, then we have over 4, 16 here, this becomes 15. So at the end of the day, we should have something like 45 over 4. All right, so it means when you take 1, you are differentiating with respect, if you are differentiating with respect to y, x will be a constant. And if you are differentiating with respect to x, y will be a constant. So please take note of that. So just the way, if you're, like when we did this now, x was treated the way you'd have treated 2, because you're not differentiating this that you have here with respect to x. You are differentiating with you are integrating with respect to y. Sorry, there's a need to write this properly. This should have been dy, and then before you have dx. All right, so that's that again. Thank you. looking at, let's take another example for your double integral. Now, supposing we have x, I'm not going to use any specific, okay, we may use a specific, let's say 0 to 2, and then we have integral of y takes value from maybe 1, maybe 5 to 10. Now, and we have x plus y. Note something, it depends. It could be the other way. X may come first, y may come first, doesn't matter. But what matters is that, so let me change it so that it can be the other way around. Let y come first. What matters is that you understand how it's done. 0, okay. We may have from 1, x takes values from 0 to maybe 2. Takes values from 0 to maybe 5. Now you have x plus y. It could be anything. So if you have x plus y, you have the x comes first, so dx dy. So x, y, okay? Now, if you are to integrate this, you are going to have, this will be equal to, so your integral, I'm not going to put, okay, let's do it. Y equals to 1, 2, 5, and then x equals to 0. Okay, now, yes, we are integrating, so let's, now, x is a constant, okay, x is not a constant because we are integrating with respect to x. So if we integrate this, we are going to have x squared over 2. All right, let's assume that we have 3 here. Now, this will be x raised to the power of 4 over 4, all right? Now, we are going to have plus, now we are integrating with respect to x, so this will become xy. So this one will become xy. So you can now, you put your limit to 0, then with respect to y. So you can now integrate with respect to y after doing your limit. Now, what about a situation where you have integral? Okay, maybe we should just finish this in a nutshell. This will become, at the end of the day, you should have something like y equals to 1. Permit me, I may be very fast, but you are going to have 2 raised to the power of 4 over 4 plus 2y dy. So this will be 5 as before. And at the end of the day, you have 2. So 2 raised to the power of 4 is 16. Okay, so at the end of the day, you have 4 plus 2y dy integral y equals to 1 to 5. Okay, so that will give you 4x plus 2xy when you integrate, so within the limit of 5 and 1. So you can finish up that one. Now, that is if you have this. But what about a situation where you have, let's do another one, where you have something like integral x raised to the power of maybe 2y like this, plus x raised to the power of 5. Something like this. Now, you need to be good with your integral stuff in order for you to be able to combat any kind of integral you may be meeting. It may be that the function has something like exponential, and then you may need to use integration by parts like that. So here, assuming x comes first, y comes last, you have dy, and then you have dx. Now, you are going to have to say, okay, this time around, let's put it in such a way that, okay, so you integrate with respect to y, you're going to have x squared to be, so you have x squared to be a constant when you are integrating with respect to y. X squared here is a constant. X raised to the power of 5 is also a constant. Anything that has to do with x that doesn't have to do with y, it may be any other letter, u, or any other number, it's a constant automatically. That's what I want you to see from everything we've been doing. This is a constant because, okay, no, this y is a constant here because you are integrating with respect to x. Since you are integrating with respect to y, x here is a constant. And in the case we took before, because you are integrating with respect to y, x is a constant. That's why we could bring it out here the other time and just integrate y on its own. All right, so going back, we are looking at that. And so since you know what is your constant now, if you are not integrating with respect to a particular thing, that thing is a constant, whatever it may be. All right, so since we are doing it with respect to y, we are integrating with respect to y, x squared as well as x raised to the power of 5 are constants. So what do we do? You just need to integrate y. How do you integrate y? So if you have a y here, let's assume this is y raised to the power of 4, or let's even have it to be y raised to the power of minus 2. Supposing that is the case, you can integrate easily. This will now become, so x, you put your x there. So since you are integrating with respect to y, the range of x will remain. So you come here, say, okay, with respect to y, this will be x squared. X squared is a constant, don't forget. Y is going to become y squared over 2. And then you are going to have x raised to the power of 5 is a constant. But y raised to the power of minus 2 is not a constant. So you are going to have y. So this will become minus 1 over minus 2 plus 1. So that becomes minus 1. And you now have it from the range of, okay, so the range of y. So dx. Now, so when you are done, when you now want to, so you're going to substitute values of y, so y goes away definitely, then you have x left, so you just integrate with respect to x. So that is how to go about that. Don't forget, your integral says integral of x raised to the power of n is equal to x raised to the power of n plus 1 over n plus 1. So don't forget that integral of x dx. So even if you have y, the same thing applies. Anything you are integrating. So that's why I could say minus 2 here plus 1 gives me minus 1 divided by minus 2 plus 1, which is also still minus 1. So that is how to go about it. So let's take just go through it again to make it better. Whenever you are differentiating with respect to a particular thing, in this case, you always start with the inner one. You are integrating with respect to y. X is a constant. So you can treat x as a constant. You bring x outside, you integrate just y. All right. So going to the next one. Here, we are integrating with respect to x. So y is a constant. So we treat y as a constant. And so that's why we've integrated the way we have. Since it's a constant, if you integrate a constant, you should get x, since you are integrating with respect to x. And we integrate x raised to the power of 3, it becomes x raised to the power of 4 divided by 4. Now, then to the last one, we are integrating with respect to y. So x is a constant. Anywhere you have x raised to the power of whatever it is. So we integrate this, we get y raised to the power of 2 divided by 2 multiplied by the constant x squared. That's how you view it anyway, why you are integrating with respect to y. So then you do the same thing for this, you get this 2. You integrate y raised to the power of minus 2 becomes this. And then before you now consider, after you substitute the limit as we have done here, you've taken care of the limit. That's when you now consider the next variable that you have. All right.